Hello class, today we're going to do two-step inequalities. Okay, so I start with this quote here on the first screen. It says, success is not final, failure is not fatal, it is the courage to continue that counts. And that's the reason why we keep pushing forward. Been through a lot this year, been through a lot over the last couple of weeks. And I know I've been through a tremendous amount, so we've got to keep pushing forward. So let's move on to two-step inequalities. So first, what I'd like for you to do for your warm-up is solve these two problems. You'll notice the first one is an equation, and the second one is a one-step inequality like you worked yesterday. Okay, however, it is a little different. You got to be careful with this one because the variable is on the right-hand side. So pause the video and answer these two questions. Okay, let's see how you did. Now in this first one, you know what I'm going to do at the very beginning. I'm going to change the subtraction to addition and the 4 to its opposite. And then I'm going to solve. Okay, and the way we do that is we add the opposite. So 2x plus negative 4 plus positive 4 equals 25 plus positive 4. So my 4's cancel out. I'm left with 2x is equal to 29. Then I divide both sides by 2. And I end up with x is equal to, well, in this one you get a couple of different answers that would be acceptable. One of them is 29 over 2, and that would work just fine. Okay, now another answer would be 14 and 1/2. That would also work because you take the 29 and you do some division. So 29 goes into 2 goes into 29, and the 2 there at one time. You multiply, you subtract, you get 0. You bring down your 9. 2 goes into 9 4 times. You get 8. You subtract, you get 1. So this 1 is our numerator. This 2 becomes our denominator. So 14 and 1/2. And then the last answer that you could have used is 14.5. Any one of those three answers would be acceptable in this problem. Now for the inequality. We know in this particular one, I'm going to do the same exact thing. I'm going to change this subtraction to addition next to its opposite. Now I'm going to show you something kind of interesting on this one. Okay, one, you'll notice that x is on the right-hand side of that inequality. So I can flip this, but you've got to be very careful when you're flipping. Okay, so I'm going to take this side, the x plus negative 9, I'm going to move it over to this side. And I'm going to take the 8 and move it to the other side. Okay, so let's see how do we do that. Well, I'm going to take the x plus 9 first, plus negative 9. And then I'm going to write down the 8. Now I notice that this inequality right here, it's eating the 8. Okay, it opens up to the 8. So that means when I flip my whole problem, I have to make sure that inequality is doing the same thing, opening to the 8. And now I solve. Okay, so we solve it the same way we did the equation. So x plus negative 9 plus 9 is less than 8 plus 9. So x is less than 17. Now to do a quick graph, we put a tick mark right there in the middle. We write 17. Now since this is just a less than, it's going to be an open circle. And because my variable is now on the left, I'm going to shade to the left because the inequality tells me which way to go. Now I want to solve this one more time real fast. Okay, so let me get rid of all this stuff here. And I want to solve this one other way. I want to solve it the way it's written. I want you to pay attention to what's going on. Okay, so I still do this. I still do my change just like always. Okay, so I'm going to start over on the x side. So x plus negative 9 plus 9. And then on the other side, I'm going to do 8 plus 9. So I get 17 is greater than x. Okay, so I put my tick mark in the middle. I put my 17. Now, if you remember correctly, I told you that if the letter is on the left-hand side, that the inequality tells you which way to shade. Well, if the letter is on the right-hand side, the inequality tells you the opposite direction. Because this says that 17 is going to be greater than x. So I need all values of x that are less than 17. So we still put a circle on the 17, and I still shade to the left no matter what. Because this 17 says that it's bigger than any of these x values. So if 17 is bigger than any of those x values, x is actually going to be on this side of the 17. So you've got to be careful with those kinds of things. Okay, so let's move on to the next one. We got one more question here for our warm-up. It says, Jessica read 40 pages of a new book the first day she bought it. After the first day, she read 10 pages a day. If the book was 350 pages, write an equation to determine how many days it will take Jessica to finish the book. Okay, now we need to understand something with this. Okay, so what we worked on in our warm-up for the first two questions, this was an equation. This is an inequality. In this particular problem, it asked for an equation. So that means I need something that's going to have an equals in it. Okay, so let's see if we can do it. It says, Jessica read 40 pages of the new book the first day she bought it. So that is a given, 40 pages. After the first day, she read 10 pages a day. Okay, so our variable is actually D for days. Okay, so we've got D for days. And what are we going to do? We're going to read 10 pages per day. So we know that 10 pages per day, 10 times D, however many days it is, plus the 40 that we read originally, equals, and now if the book has 350 pages, equals 350. Now what we have to do is solve this one. So what I want you to do is pause the video and solve the problem. Okay, so let's see how you did. Okay, so first I need to get rid of the 40. So 10D plus 40 plus negative 40 equals 350 plus 40, or plus negative 40, sorry. So my 40s go away, and I'm left with 10D is equal to, and then 350 plus negative 40 gives me 310. So I divide both sides by 10, and I end up with D is equal to 31. But if you only gave me 31, then I'm going to take off points, because in a word problem, that 31 has a label. And what will our label be? In this case, pages. And how do I know that? It says, how many days will Jessica take to finish the book? Oh, would it be pages? Oh, is it really? No, it's not actually. Okay, so that's one of the things, though, that we think about, that we think it could be. But what did it say we want? It says how many days. So what's my label really going to be? Days. Very good. So don't be fooled on that label just because of what it's talking about, okay? Because it's got pages and pages and pages, and you may think that one needs pages as well. So be very careful, okay? Make sure that when you are trying to find out what label goes on there, that you read the question to figure that out, okay? So now let's move on with our lesson. So today what we're attempting to do is represent solutions for one variable, two-step equations and inequalities on number lines. And we're going to try to model and solve two-step equations and inequalities. So the part that we're going to be dealing with is the two-step inequalities on a number line, okay, and talking about representing solutions. And we're going to be solving two-step inequalities. So that's the part of the 7th grade standard that we're going to work on today. So let's start by reviewing one-step inequalities. Let's see what you remember from yesterday's lesson. Okay, so in this first one, we've got x plus 7 is less than or equal to 5. So we know we solve it just like we do an equation. So x plus 7 plus negative 7 is less than or equal to 5 plus negative 7. So we end up with x is less than or equal to negative 2. Now, to check this, what you need to do is pick a value that's within this set, within the solution set, to see if it works. So it says x has got to be less than or equal to negative 2. Okay, so let's graph it first, and then we'll pick a value to check it with. So we first put a tick mark down here, and we put a negative 2. Now this says we're going to be less than or equal to. Okay, so that means that we're going to have a closed circle. And we want it to be less than or equal to, so that means left of negative 2. So give me a value that is less than negative 2. Never choose the equal part, because it'll always work. Always choose a value that is part of the less than part, okay, or the inequality part there. Okay, so a value less than negative 2, negative 3. So if I were to plug in a negative 3 here, negative 3 plus 7, is that less than or equal to 5? Well, negative 3 plus 7 is 4. So is 4 less than or equal to 5? Yes, it is. Okay, very good. Now, if you remember multiply and divide, they were a little different. Okay, we had to be really careful on multiply and divide. Okay, but let's start with what we are used to with solving equations. So in this first one, I have a multiply by 3. I have a multiply by 3 right there. Okay, so to get rid of that, I have to do a divide by 3. And if I do that on one side, I got to do it on the other. And I end up with m is greater than negative 7. M is greater than negative 7. Okay, so in order to check that, let's graph it first. So put a tick mark, put a negative 7, and it says I need to have a value greater than negative 7. So that means it starts at 7 or negative 7 with an open circle, and we shade to the right. Now, anytime I can choose 0 as a value to plug in, I would like to do that. So in this particular one of the numbers in the solution set of m is greater than negative 7 is 0, because 0 would be over here somewhere. So I could plug 0 in. 3 times 0 is greater than negative 21. Well, 3 times 0 is 0. Is 0 greater than negative 21? Yes, it is. So it works. Okay? Now, let's talk about this one. Okay, the last question here. So in this one right here, we've got x divided by negative 4 is greater than or equal to 2. So if we solve this one just like normal, just like we did an equation, we would have, how do I get rid of a divide by negative 4? I do a multiply by negative 4. If I do that on one side, I do it on the other. So we'd end up with the 4's dividing out, and we get x is greater than or equal to negative 8. Okay, so if I graph this, okay, and this is going to be a closed circle on negative 8, and it says greater than. Okay, so that is the solution set that we choose on this particular one right now. Okay, so I pick a value in that one. Well, one number that's greater than negative 8 is 0. Okay, so I'm going to plug that in. Okay, so plug it back into the original problem. So 0 divided by negative 4 is greater than or equal to 2. Well, 0 divided by negative 4 is still 0. It's greater than or equal to 2. Is that correct? Uh-oh, that's not correct. So what did I do wrong? Oh, I remember. Okay, so let me come back here. Let's talk about this here. Let me get rid of all this. Let's find, what did I forget about? Oh, let's see. If I multiply through or divide through by a negative number, what's going to happen to my inequality? My inequality is going to flip. So if I multiply through by a negative number or divide through by a negative number, so if the number with your x, the coefficient, is negative, then my inequality is going to flip. Okay, so now this really is negative 8. It's still a closed circle, but instead of being shading this direction, I really need to shade less than negative 8. So now to check this one, I need to pick a special number. I need to pick a number that is less than negative 8, but is divisible by 4. So the first one is 12. Okay, so I'm going to use negative 12. So negative 12 divided by negative 4 is greater than or equal to 2. Now, why would I want to do that? Why would I want to pick a value that's less than negative 8 but divisible by 4? So I can divide here and have a nice pretty number. So negative 12 divided by negative 4 is 3. Is 3 greater than or equal to 2? And yes, it is. So again, we have to remember, if I multiply through or divide through by a negative number, my inequality must flip. Okay, so I've got a question for you. Would two-step inequalities be worked the same way as two-step equations? Yes, it would. Okay, so we just got to remember, step number 1, get rid of your addition or subtraction, add the opposite. Step 2, get rid of your multiply divide, do the opposite. If you have a negative coefficient, flip the inequality. Okay, so let's see if we can do that. So here's our first two-step inequality. Okay, so we're going to solve this one exactly the same way as we do with equations. But the one thing I want you to look at before you even begin is 1, check out and make sure that everything is correct. Make sure there's no minus. Okay, the second thing I want you to check is look at your coefficient and determine, is my inequality going to flip? So in this one right here, my coefficient is positive, so my inequality will not flip. So I work it exactly the same way I would work an equation. So 2x plus 5 plus negative 5 is greater than 7 plus negative 5. So my 5's add out. I get 2x is greater than, and then 7 plus negative 5 gives me 2. Okay, so I divide both sides by 2. I end up with x is greater than 1. So I come over here to do a quick graph. I put a tick mark, I put a 1, I put an open circle on 1, and I shade to the right because I need all values greater than 1, okay, which is to the right of 1. Okay, so let's look at another one. Oh, now this one's a little bit tricky. Okay, notice what I've done to you on this one. Okay, you'll notice that my x's are on the right-hand side. Now, earlier we did a one step that was like this. Okay, so what could I do? Okay, could I flip this one? Yes, I could. First thing I want you to look at, though, is make sure you have an addition problem. Okay, then you can flip it. Okay, so I'm going to take this whole right-hand side. I'm going to write 3x plus 5. Then I'm going to take the left-hand side. I'm going to write 22. And then I'm going to look at my inequality. My inequality opens up to the 3x, or it points to the negative 22. So I need to make sure that it does the same thing when I flip it. And now we solve it. Okay, so once we've got it like this, make sure again it's plus, and look at your coefficient. Is it positive or negative? In this case, it's positive, so we work it exactly the same way. Pause the video and solve this problem. Okay, so let's see how you did. So you should have done 3x plus 5 plus negative 5 is greater than or equal to negative 22 plus negative 5. So that gives you 3x is greater than or equal to, and then negative 22 plus negative 5 gives you negative 27. Divide both sides by 3, and you end up with x is greater than or equal to negative 9. Okay, so I come to do my quick graph. Okay, I put a tick mark. I put a negative 9. This is going to give me a closed circle on negative 9, and I'm going to shade to the right because I need values that are greater than negative 9. Now, I'm going to check this one just to make sure. One value that is within this solution set right here is 0. So I'm going to plug a 0 in. So negative 22 is less than or equal to 3 times 0 plus 5. So negative 22 is less than or equal to 3 times 0 is 0 plus 5 is 5. So negative 22 is less than or equal to 5. So it works. Okay, let's try another one. What about this one? Okay, so the first thing you notice in this particular problem is we have a minus. So we need to fix that. So I fixed that. The second thing that I need you to notice is, my coefficient is negative. So what's going to happen at the end of the problem? My inequality is going to flip. So you might want to notice it's pointing to the left. Make sure kind of at the end that it's pointing to the right. Just kind of put that there just as a reminder. Okay, so now we just solve the problem. First thing I do is I get rid of the negative 12. So negative 8x plus negative 12 plus 12 is less than 12 plus 12. Okay, so my 12s on this side go away. I'm left with negative 8x is less than, and 12 plus 12 gives me 24. So don't do anything to that inequality until we're ready to. So now I need to get rid of the negative 8. So I'm going to divide by negative 8, divide by negative 8, and I get x. And then my 24 divided by negative 8 gives me a negative 3. But what do we have to remember to do? Flip the inequality. Because this negative here kind of acts like a hook, and it hooks the inequality and flips it. So instead of it being x is less than negative 3, our answer is actually x is greater than negative 3. So I come over here, I put a tick mark, put a negative 3. It's going to be an open circle, and I need all values to the right of negative 3. Well, again, one of the values is 0, so I can use that to check it. So negative 8 times 0 minus 12, or plus negative 12, is less than positive 12. So negative 8 times 0 is 0. Minus 12 gives me negative 12 is less than positive 12. Is that a true statement? Yes, it is. All right, and that's how we solve two-step inequalities. I'm going to give you one more. This next one's going to be kind of tricky. Oh my goodness, we got division. Okay, so let's take a look at this one. I'm not going to solve it all the way, but let's just kind of look at what I need you to look at. Okay, so in this one right here, do we have plus? Yes. Do we have a negative coefficient? No. So is my inequality going to flip? No. Okay. What about this one? Oh, no, this one is really tricky. Okay, so I keep hitting the wrong buttons there. Now, in this one, what do you notice is funky? Okay, one, it's minus, so I'm going to change this subtraction to addition next to its opposite. Okay, so now everything's plus. Now, what do you notice about the coefficient? My coefficient's negative, so what's going to happen? My inequality is going to flip. Now, at this point, could I rewrite the problem? Yes, I could. You could rewrite it as negative 2x plus 8 is less than 18. And then remembering at the end that right now it's pointing to the left. So that means I need my inequality to be pointing to the right when we solve it. Now, what if I gave you something like this? Oh, my goodness. Okay, well, do we do it the same way? Yes. You change subtraction to addition next to its opposite. Okay, do you notice, what about my coefficient there? Okay, it's negative. So what's it going to do to that inequality? It's going to flip. Okay, now working with decimals, is it going to be any different? No, you do it exactly the same way. And that's how you solve two-step inequalities. So what I'm going to have you do, okay, we'll look at the rest of those here, at another lesson. So what I'm going to give you is I'm going to give you some problems, okay? And you'll notice in these problems right here, on question 1, 2, 3, and 4, I'm asking you to solve it and graph it, okay? On question 5 and 6, same thing, solve it and graph it. And then on your assignment, the one that's digital, okay, it's got 18 questions on it. It's got 6 more, but all I want you to do is through number 12. Now on 7 through 12, okay, you don't have to graph those. Only graph the problems that come with a graph, okay? And that's how we solve two-step inequalities. So until next time, I'll talk to you later.